Good day, good day, guys. Can you hear me clearly? Hello, guys. Can you hear me clearly?
Yes, sir.
All right. So, good afternoon. We'll be dealing with combination today. I know we sent a video on combination for the last class, but I bet most of you didn't even watch the video. And then we are leaving no room for discrepancy. So, we want to make sure we cover up every part. So, now in our previous class, the one I did with you on Friday, we dealt with combination. Now, we say when we are dealing with combination questions, order matter. You see, when we are dealing with combination questions, all that matter. Now, sorry, when we are dealing with permutation questions, all that matter. When we are dealing with combination, combination also talks about selecting, but order does not matter. The arrangement does not matter. Combination also talks about selecting, where you are choosing, but the order does not matter. You are not arranging here, you're only selecting. Let's take, for instance, now, I have 30 people and I'm told to select 10 people to be in a football team. The order in which I select them does not matter. I'm only selecting just 10 people. So the order does not matter compared to permutation, where we are saying first, second, third, there are three different people, so the other matters. But for this one, the people I'm selecting 10 people to be in a football team from a list of 30. The order in which I select them do not matter. Now, combination also has its own formula. For the formula for combination, we have n combination R is equals to n factorial over n minus R factorial R factorial. Now, looking at this, where we say n is the total objects, and we say the R is the object. We talked about this when we were dealing with permutation for selected objects. Right, so let's move into solving question. Let's look at cheap questions first, then we move into the tougher ones. What do you say? What do you say? Right, so looking at this question, I got told to choose 3 students from 5 students. How do I know this is a combination question, not a permutation question? If you observe, if you are going through questions in your PQ, nobody will tell you this is a permutation question. Nobody will tell you this is a combination question. So you have to always figure out if it is permutation or combination to know which formula to use. I see the formula for combination is quite different from that for permutation. That's for permutation, this part is not there. But this for combination, we have alpha factorial here. Now, how do I tell that this is a combination question? They say I'm told to choose 3 students from 5 students. Now, we have 5 students arranged. I'm told to choose 3 from them. I'm not told to choose only girls. If I was told to choose only girls, now that's looking like there's a particular selection. I'm not told to choose, okay, choose only those. But looking at it, I'm just told to choose 3 people from a student of 5. So it shows that it is combination. I'm not told to choose them in a particular order. We are selecting just 3 from 5. So using my formula now, we say n combination out. We say n is the total objects. My total object here is 5. My total object is 5 students. Why my selected object is 3? We are selecting 3 students from the total 5. Implementing this, we'll be having 5 combination 3 is equals to n factorial, which is 5 factorial, divided by n minus r5 factorial, which is 5 minus 3 factorial, then r factorial, which is 3 factorial. Simplifying this, we'll be having 5 factorial over 5 minus 3 factorial. 5 minus 3 is 2 factorial, so we'll be having 2 factorial, 3 factorial. Simplifying this now, I can bring this one down to 3 factorial because I want to cancel it out. Let me write this here first. We have 5 factorial over 2 factorial, 3 factorial. So this is equals to 5 factorial. Sorry, breaking it down now, simplifying it, so we're having 5 times 4 times 3 factorial divided by 2 factorial is 2 times 1. 2 times 1, then I have my times my 3 factorial. Now 3 factorial is cancelling out 3 factorial. 2 here 1, 2 here 2. I'm left with 5 times 2, which is equals to 10. So it is simply equals to 10 ways. So we can choose 3 students from 5 students in 10 different ways. Is it clear, guys?
Yes, sir.
All right. Right, so let's look at the second one. And so a class activity, how many committee of three can be formed from 8 students? I don't think this should take more than 1 minute. So I'm waiting for you guys. Just 1 minute. How many committee of three can be formed from 8 students? No answer yet. It's 1 minute already. Okay, someone said 8 in the group chat. Okay, just one more person there will post it. Nobody. Let's look at it together. One thing I don't want is I don't want us to mix up combination and permutation. Now, look at this now. I'm told to select 3 people. How many people can be formed from 8 students? Say how many committee of three can be formed from 8 students? Let's assume I have 8 students to be A, B, C, D, E, F, G, H. 1, 2, 3, 4, 5, 6, 7, 8. Now let's say these are the names of my 8 different students. Now I want to choose 3 people from here now. I'm not told any order to choose it. I'm just told to just select 3 people. That's if they just gave me a chance, like something of convenience that select any 3 people you like. That's when we talk about combination. I'm selecting, I'm not told that arrange them in this way or do any way. I'm looking at this now. Let's say I have two, three. Let's say I have 2, 4, 6, and 8. And I'm told how many different 3 digits can be formed. How many different 3 digits can be formed? All right, comparing this to this now, yeah, I'm told how many different 3 digits can be formed from this now. This is a permutation question. How do I know? Because if I'm forming 3 digits now, I can't just say I'm just saying 2, 4, and 6. No, I have to try all the way. So the arrangement is comes in matters. I can say 2, 4, 6. This is one 3 digit. I can say 2, 4, 8. I can say 2, 6, 8. I can rearrange and rearrange and rearrange. So for permutation, the arrangement matters because 2, 4, 6 is not the same thing as 2, 6, 4. It is different things. 248 is not the same thing as 284. This is another arrangement. That's why you say arrangement matter. So whichever question you're solving, if you are dealing with permutation, you always know that arrangements matter. For this one, I'm just selecting. I'm only selecting. I'm told to select only 3 people. I can decide to select C, D, and E. I'm sorted. I'm selecting only 3 people. So let's look at it together now. I'm just trying to make you guys know how to differentiate questions of combination from that of permutation. Now looking at this now, I'm told how many committee can be formed. Okay, sorry. How many committee of three can be formed from 8 students? What do I do? We say this is a combination question. So what's our formula? We say our formula is n combination r is equals to n factorial over n minus r factorial r factorial. Taking this into place, my n we say is for the total. Total is 8. So I have 8 combination. Our r, which is the selected, we are selecting just 3. 3 is equals to n 8 factorial over n minus r, which is 5, sorry, 8 minus 3 factorial, and our r 3 factorial. Subtracting this, we'll be having 8 factorial over 8 minus 3 is 5. 5 factorial, then 3 factorial. So we can break this down in order to cancel it out with this. Breaking it down, we'll be having 8 times 7 times 6 times 5 factorial. Because I have 5 factorial, that one I also cancel it out. All divided by 5 factorial, 3 factorial. 5 factorial is cancelling out 5 factorial. I still have 3 factorial here, so I can break it down to, I'm left with 8 times 7 times 6 divided by 3 factorial is 3 times 2 times 1. 3 here is 1, 3 here is 2, 2 here is 1, 2 here is 4. So 4 times 7 times 2. Who can help us with that? 4 times 7 times 2. What's the answer? 4 times 7 times 2. I think guys, 4 times 56. 4 times 7 times 2 is 56. The answer is simply 56. Is it clear? Hello, class, is it
Yes.
clear?
Yes, it is.
Yes.
All right, so let's go to some questions from our PQ. Let's go to page 15, question 31. Unilag PQ here. Page 15, question 31. Page 15, question 31. Yeah, so we are told in how many ways can 3 monitors be selected from a class of 20 students? In how many ways can 3 monitors be selected from a class of 20 students? Look at this one. Now we are told to select 3 monitors. We are not told arrangement matters. We are only selecting. We are not told the way we arrange them matters. So obviously, this is a combination question. So who can help us with this? What's the answer? Who is helping us with it? What's the answer? I'm waiting no class. Still nobody. This is like 2 weeks to our exam, so and this one that you people are looking lost. Okay, let's look at it together now. Okay, yes, someone said something there. Okay, 1,140. Okay, Esther said 1,140. Okay, let's look at it together. We say since this is a combination question, what are we doing? We are using our combination formula. N combination R is equals to N factorial over N minus R factorial. R factorial. And what's our N in the question, guys? What's
20.
our N in the 20? Our
20.
N is 20. How about our R? What's our R in the question? Yeah, while it's three. So if you know this one, you already know your answer. I don't know why you guys are not telling me the answer. Once you know your n and you know your and you know your formula, then you're not having any issue. You are replacing your n with your value for n, and you are replacing r with your value for r. So I have 20 factorial of this is divided by n minus r, 20 minus 3 factorial, then 3 factorial. This is equals to 20 factorial over 20 minus 3 is 17. 17 factorial, 3 factorial. Now I'm reducing this one now to 17 because I want to do 17 instantly 17. Reducing this one, I'll be having 20. We say 20 factorial is 20 times 19 times 16 times 17 till you get to 1. But because I have 7 factorial, instead of doing 17 times 16 till that, so I can just stop here at 17 factorial, then I'll cancel out both of them. Doing that now, I have 17 times 19 times 18 times 17 factorial, all divided by 17 factorial 3 factorial, or 17 factorial multiplied by 3 factorial. Now 17 factorial is cancelling 17 factorial. Instead of writing 3 factorial here now, I can say 3 times 2 times 1. That's breaking it down. We have 3 times 2 times 1. And now we have 3 here, 1. 3 in 18 is 6. 2 here is 1. 2 in 20 is 10. So 10 times 19 times 6. Guys, 10 times 19 times 6.
1,140.
Eh?
1,140.
1,140. So answer is simply 1,140 ways. Very simple, guys. Is it clear? Hello, class. Is it clear?
Yes.
Yes,
Okay. Right now, still in a position past question. Let's go to page 27, question 10. Page 27, question 10. Now, looking at this question, it seems quite complex, but then it's still the same thing with what we have been doing. Now, looking at this, we say there are 8 men and 9 women on the committee. There are 8 men and 9 women on the committee. In how many ways can a subcommittee of 2 men and 3 women be chosen? Say there are 8 men and 9 women on the committee. In how many ways can a subcommittee of 2 men and 3 women be chosen? Looking at this now, we are only choosing 2 now. Looking at it, reading it and interpreting, we are told you have 8 men. So let's say we have 8 men. Then how many women? We are told we have 9 women. 9 women. Now, from this total of 8 men, we are told to select 2 men. We are selecting 2 from this total of 8 men. Then why from the total of 9 women, we are told to select 3. We are selecting 3 women. Now, looking at this, how can you tell this is a combination question? I'm only selecting 2 men from 8 men. I'm not told select someone to be vice president and president. I'm not told select someone to be treasurer and PRO. Now, let me tell you where that comes in place now. Let's assume I want to select 2 men from 8 men now. And I'm told the 2 men I want to select, one is going to be a PRO and one is going to be the VP. This is going to be a permutation question. I'll tell you why this is a permutation question now. If I was told to just select 2 questions from 8 men now, that is a combination question. But if I'm told to select 2 men, and one should be the PRO and one should be the vice president now, after selecting the 2 of them, after selecting the 2 men now, is either the first man is PRO, the second man is VP, or the second man is PRO, the first man is VP. Let's give them a name. Let's say this is Bola, and this is Femi. So even after selecting the 2 men from these 8 men, if I was told one is to be PRO and one is to do BVP, so if I select Bola and Femi now, is either Femi is the PRO and Bola is the VP, or Femi is the VP and Bola is the PRO? Can you see that arrangement matters in this one? That is why it is a permutation question. Because I still have to arrange them that, Is either this one is VP and this one is PRO, or this one is PRO and this one is VP. So all that still matters there. That one is permutation. But this one, we are told to just select two men out of this one. The way you select them, I'm only selecting two men. I select Bola and Femi. The arrangement in which I can choose to select Bola or Femi, anyone first. The arrangement does not matter because I'm only selecting them. Is it clear, guys?
Yes, sir.
All right, now going
Yes.
further, now you are told to select two men from 8 men. What do? You are putting that separately. We have 8 combination 2. I'm selecting 2 men from 8 men. So I have 8 combination 2. Then multiplied by that of the women. You are told to select 3 women from 9 women. Multiplied by 9, which is the total women. Combination 3, which is the sum. Solving for this one now, 8 combination 2 is simply equals to 8 factorial over 8 minus 2 factorial, which is 6 factorial. And we have 2 factorial. That's for the first part. Breaking this down further, we have 8 times 7 times, times 6 factorial divided by 6 factorial. Two factorial is 6 multiplied by 9. 1 here 1, 2 here 4. 4 multiplied by 4. So for the men, we have to now calculate for the women part. Now calculation for the women, we take 9 combination 3. 9 combination 3 is equals to 9 factorial over 9 minus 3 factorial, which is 6. Then 3 factorial. The next thing you guys are not understanding, let me know it. Because I thought you have been doing this process, that's why I'm not writing it. Breaking this down now, we have 5 times 8 times 7 times 6 factorial divided by 6 factorial. Then multiply by breaking this 3 factorial down, so we have 3 times 2 times 1. This factorial is cancelling out 6 factorial. 3 here 1, 3 here 8 is 4. 3 here 1, 3 here is 6. So 6 multiplied by 4 multiplied by 7 is what, guys? 6 times 4 times 7. Guys, 6 times 4 times 7.
168.
150. So are we done? No, we are not done. We are done for that of women. We are done for that of women. So to get the total, you have to multiply it. Multiplying this now, our answer is simply 168 multiplied by 2.
Sorry, sir, we can't.
We can't
I
see
can't
you.
hear. You cannot see you or hear you. Yes. Sir?
How
about
about now? Can you hear me now?
No.
You can't still hear me.
Oh, we can hear you. We can hear you, but
Okay,
see you. No.
Okay, sorry about that now. Can you hear me and see me now? So what's
Yes, sir.
168 multiplied by 28?
Oh,
168 multiplied by 28. Nobody's talking. What is 168 multiplied by 28? Are you sure you people are hearing me, sir? Class, what is 168 multiplied by 28? Oh? Someone said they don't think it's 168. Who multiplied? Who multiplied this part for? Sorry. What's 6 times 4 times 7? I'm working with you guys now, so I feel I'm carrying you along. What's 6 times 4 times 7?
That's 6 times 4
168.
times 7 is 168, but it's not meant to be 6 times 4 times 7.
Yes.
Okay, what's it supposed to be? We have 2 here 1. 2 here is 4. Then we have 3 here 1. Okay, 3 in 9 is 3 in 9 is what? 3 in 9 is 3, right? Are we good now, guys?
Yes, sir.
Yes,
All
sir.
right, so what's 3 times 4 times 7?
84.
All right, so we
Yes.
have 84 here. So 84 multiplied by 28. 84 multiplied by
2003.
eh?
2,356.
2,356. Our final answer is simply 2,356.
Two, sir.
Okay,
That's
2,356.
meant
So
to be
that's
two
option,
now.
that's option D, 2,352. Is it clear, guys?
Yes, sir.
All right. All right, so let's move on to the next question. We have page 28, question 30. Page 28, question 30. So now we are told, in how many ways can a group of 5 men and 2 women be made out of a total of 7 men and 3 women? This is similar to what we just solved, so I'll leave it to you guys. 1 minute. 1 minute, guys. Question 30. Can you see the screen now? Hello, class. Can you see the screen now? All right. Nobody's done care.
If I
What do
will
you say?
help.
Are you talking to me? Okay, someone said D. What's the option
Answer
for
is
D? The answer is what?
63.
63.
No, the answer is 63.
63. The answer is 63. So I believe we are clear on this aspect.
Please use down this. We will send.
Say the answer is 63, but then let's still look at it together. For those of us that might not know how we arrive at
Where have you been?
that.
Madam Oaks.
Well, that's question. What is
And
that? Okay. Question 30. Now, we've seen how many ways can a group of 5 men be selected from 7 men? So we have 7 men.
where
I
am
want
I?
to select 5 men. Then we have 3 women. And we want to select 2 men. Okay. Right, so now selecting this, now you see we are selecting 5 from 7, that's 7 combination 5. Or we are selecting 2 from 3, that's 3 combination 2. Then we are multiplying this. So we have 7 combination 5 multiplied by 3 combination 2. Bringing this separately, we say 7 combination 5 is equals to 7 factorial divided by 7 minus 5 factorial, which is 2 factorial, then 5 factorial. Breaking this down further, we'll be having 7 factorial. We want to cancel out 5 factorial, so we'll be having 7 times 6 times 5 factorial divided by 2 factorial. 2 factorial is 2 times 1. And we have 5 factorial. 5 factorial is cancelling out 5 factorial. We have 2 year 1, 2 year 3. 7 times 3. What's 7 times 3, class?
21. 21.
Yeah. So we have 7 times 3 to be 21. So we have solved for the main part. Now solving for the other parts now. You say we are selecting 2 women from 3. That's 3 combination 2. So 3 combination 2 is simply equals to 3 factorial over 3 minus 2 factorial, which is 1 factorial. Then we have our R, which is 2 factorial. 3 factorial is 3 times 2 factorial divided by 1 factorial, 2 factorial. 2 factorial is cancelling out 2 factorial. 1 factorial is 1. Then we are left with 3. So we have 3 here. So we have gotten the one for women to be 3 and the one for guys to be 21. So multiplying it, therefore, the total weight should be 21 multiplied by 3. And what's 21 times 3, class?
63. 63.
21 times 3 is 63. The answer for that is simply 63. Right now, so I want us to look at other ways they can solve, they can set their questions now. So looking at this now, guys, we are told a committee of 6 is to be selected from 10 men and 7 women. Now, if the committee must contain exactly 4 men and, okay, 4 men, how many committees are possible? Now, why trying to interpret this? Now, we were only told for men, we were not told how many for women. Interpreting this now, we say we are selecting exactly 4. If they say exactly 4, that means we are selecting only 4 women. What does that mean? That means we are selecting, sorry, only 4 men. What does that mean? That means we are selecting 4 men from the total 10 men. So for the men, we'll be having 10 combination. The 4, they say we are selecting exactly 10 men. We are selecting 6, but the ones only 4 of them should be from the men. 10 combination 4. Now multiply that by, now for women now, who can tell me how many women will be selecting? Guys, how many women are we selecting? That's why interpretation is very important. Now, going back to the beginning of the question, you say a committee of 6. That means the total we want to select is 6. In the previous question, now we are told, okay, select 2 guys and select 3 females for maybe a total of 7 and 5. So now we are selecting 2 and you are selecting 4. That means 2 plus 4 is 6. That means the total you are still selecting is 6. Can you still hear me, guys? Hello, class. Can you still hear me?
Yes.
What do you say? Hello, can you hear me? Are you with me?
Yes, sir, we can.
Okay, right. I was saying if it was the previous question, we are told the amount of women and the amount of men. But this one, we want to select 6. We want to select a committee of 6. Now, if we are told that 4 men should come from there, what does it mean? It means we are left with just 2 options. So if we are selecting exactly 4 men, what does that mean? It means we are selecting 2 from the women part now. We want to select 6 committees. If we are selecting 4 from the men, what does it mean? We are left with just 2. So the 2 is coming from the women's side. Is that logic clear? Hello, class. Is it clear?
Yeah. Yes, sir.
All right.
Yes, sir. So if you are selecting 4 from the men's side, this means the remaining 2 is coming from the ladies' side. So what are we multiplying with this with? The total is 7. So we have 7 combination, the 2 we are selecting from the ladies. Breaking this down now for the main part, solving the main part first, we have 10 combination 4, which is equals to 10 factorial over 10 minus 4 factorial, which is 6 factorial. Then we have our 4 factorial. Breaking this down, we'll be having 10 times 9 times 8 times 7 times 6 factorial divided by, we have 6 factorial, and I have to break my 4 factorial down. Breaking it down, we're having 4 times 3 times 2 times 1. We don't need the 1, so then 6 is cancelling 6. Now we have 3 year 1, 3 years 3. 2 year 1, 2 in 10 is 5. And 4 year 1, 4 in 8 is 2. So I have 5 times 3 times 2 times 7. Okay, sorry, 2 year 1, 2 years 4. I'm sorry, guys. 2 year 1, 2 year 4. Right? So 5 times 3 times 4 times 7 is what, class?
3 times 1.
I'm sorry, guys. We did 2 year 1,
210,
2 year
210.
5. 2 year 1, 2
This
years
is
5.
fine.
3 year 1, 3 in 9 is 3. Then 4 year 1, 4 in 8 is 2. So 5 times 3 times 2 times 7.
210.
Someone said 210. Please, guys, confirm. Is that right? Is 210 correct?
Yeah, it's 110. Wow.
210. All right, that's for the men's part. Now for the ladies. So for the women's part, for the women, we have 7 combination 2. So 7 combination 2 is simply equals to 7 factorial divided by 7 minus 2 factorial, which is 5 factorial, then 2 factorial. Breaking it down, we have 7 times 6 times 5 factorial divided by 5 factorial, 2 factorial. 2 factorial is 2 times 1. So 5 year 1, 5 year 1. 2 year 1, 2 year is 3. 3 multiplied by 7 is what? 21. So for our final answer, what's 210 multiplied by 21, class? 210 multiplied by 21.
4,410.
4,210. Is that